exception 4 to NEC 501.15b2 addresses sealing requirements for conduit systems extending from Class 1 Division 2 locations. This exception is particularly relevant when dealing with explosion-proof enclosures and associated wiring in hazardous environments. To understand this exception fully, we need to dissect the specific conditions under which it applies. The core of the exception revolves around a conduit system that runs entirely outdoors. This means the entire length of the conduit, from its starting point within the Class 1 Division 2 area to its termination point, is exposed to the external environment. The exception states that if this condition is met, a seal is not required at the boundary between the Class 1 Division 2 location and the unclassified area. It's important to note that the presence of an unclassified area is a key element. This is a space where ignitable concentrations of flammable gases, vapors, or liquids are not normally present. The purpose of seals in conduit systems within hazardous locations is to prevent the passage of flammable vapors, gases, or liquids from a hazardous area to a non-hazardous area. This helps to contain potential explosions or fires within the designated hazardous location. However, when a conduit system is entirely outdoors, the natural ventilation and dispersion of any potential leakage significantly reduce the risk of hazardous substances migrating to the unclassified area. The exception recognizes this reduced risk. Consider a scenario where an explosion-proof power panel is located in a Class 1 Division 2 area near a pump house, as previously described. The conduits run from this panel a distance of approximately 150 feet to a motor control center building. A portion of the conduit run, say 20 feet, extends past the explosion-proof panel into an area that is classified as Division 2, before reaching the unclassified area. Now, if this entire 150-foot conduit run is installed outdoors, then exception 4 to 501.15b2 applies. This negates the requirement for a seal at the point where the conduit exits the Division 2 area and enters the unclassified area, regardless of whether the conduit eventually runs indoors at the Motor Control Center building. A common point of confusion arises when the conduit, after being entirely outdoors, eventually enters a building housing the Motor Control Center. Some may argue that since the conduit ultimately terminates indoors, the exception should not apply. However, the NEC is clear in its wording. The exception applies if the conduit run is entirely outdoors. The NEC focuses on the path of the conduit itself, and as long as that path remains in the open air, the exception holds. In summary, firstly, the conduit system must be entirely outdoors from the explosion-proof panel to its termination point, regardless of what happens beyond that point. Secondly, the area into which the conduit run extends must include an unclassified area. Thirdly, the absence of a seal at the Division 2 boundary is permitted under these specific conditions. Understanding this exception can lead to cost savings and more efficient installations without compromising safety. The exception allows for the elimination of unnecessary seals, which can be expensive to install and maintain. However, it is crucial to meticulously assess the installation to ensure that all the conditions of the exception are met. Any deviation from these conditions may invalidate the exception and necessitate the installation of a seal. For example, if even a small portion of the conduit run is located indoors or underground, the exception would not be applicable. Similarly, if the area beyond the Division 2 boundary is still classified as a hazardous location, the seal would still be required. Let's consider some additional factors that might influence the application of this exception. Firstly, ambient temperature. Extreme temperature variations can affect the performance and integrity of seals. If the conduit system is exposed to extreme temperatures, it is crucial to select seals that are rated for those conditions. Secondly, chemical exposure. The presence of corrosive chemicals in the environment can degrade the sealing compound and the conduit itself. In such cases, it is essential to use materials that are resistant to the specific chemicals present. Thirdly, mechanical stress. The conduit system may be subjected to mechanical stress due to vibration, movement, or physical impact. Seals should be selected and installed in a manner that can withstand these stresses without compromising their integrity. Consider the specific components involved in an explosion-proof installation. Firstly, explosion-proof enclosures. These enclosures are designed to contain any internal explosion without allowing it to propagate to the surrounding atmosphere. They are typically made of heavy-duty materials such as cast iron or aluminum and are designed to withstand high pressures. Secondly, explosion-proof conduit and fittings. These components are designed to maintain the integrity of the explosion-proof enclosure and prevent the passage of flames or hot gases. Thirdly, seals. Seals are used to prevent the passage of flammable vapors, gases, or liquids through conduit systems. They are typically installed at the boundary between hazardous and non-hazardous locations. Fourthly, intrinsically safe barriers. These barriers are used to limit the amount of energy that can enter a hazardous location, preventing ignition. The NEC provides detailed guidelines for the selection, installation, and maintenance of explosion-proof equipment. It is essential to adhere to these guidelines to ensure the safety of personnel and property. In addition to the NEC, other standards and regulations may apply depending on the specific location and application. These may include local building codes, fire codes, and insurance requirements. It is important to consult with qualified professionals who have expertise in hazardous location electrical installations. These professionals can provide guidance on the selection of appropriate equipment, the proper installation techniques, and the ongoing maintenance requirements. Proper documentation is crucial for explosion-proof installations. This documentation should include detailed drawings, specifications, and inspection reports. It should also include a record of any maintenance or repairs that have been performed. This documentation can be invaluable in demonstrating compliance with applicable standards and regulations. Ongoing inspection and maintenance are essential for ensuring the continued safety of explosion-proof installations. Seals should be inspected regularly for signs of damage or deterioration. Conduit systems should be checked for corrosion or mechanical damage. Explosion-proof enclosures should be inspected to ensure that they are properly sealed and that all components are in good working order. Any deficiencies should be addressed promptly. The technology behind explosion-proof equipment is constantly evolving. New materials, designs, and techniques are being developed to improve the safety and reliability of these installations. It is important to stay abreast of these developments and to incorporate them into your designs and practices. For example, advancements in sealing compounds have led to the development of materials that are more resistant to chemicals, temperature variations, and mechanical stress. Similarly, new types of explosion-proof enclosures are being developed that are lighter, stronger, and more resistant to corrosion. In conclusion, understanding the nuances of NEC 501.15b2 Exception 4 is crucial for anyone involved in the design, installation, or maintenance of electrical systems in hazardous locations. By carefully considering the specific conditions of the installation and adhering to the applicable standards and regulations, it is possible to ensure the safety of personnel and property. Remember that even when an exception applies, it is always prudent to err on the side of caution and to consult with qualified professionals when in doubt. Safety should always be the top priority in any hazardous location electrical installation. It is also beneficial to consider the implications of future changes to the NEC. The NEC is updated every 3 years, and these updates may include revisions to existing requirements or the introduction of new requirements. Staying informed about these changes is essential for ensuring that your installations remain compliant. For example, future revisions to 501.15b2 could potentially modify the conditions under which Exception 4 applies. These modifications could be driven by technological advancements, changes in industry practices, or a desire to enhance safety. Therefore, it is important to actively participate in the code-making process and to stay informed about any proposed changes to the NEC. This can be accomplished by attending industry conferences, subscribing to relevant publications, and participating in online forums. In addition to the technical aspects of explosion-proof installations, it is also important to consider the human factors. Training and education are essential for ensuring that personnel who work in hazardous locations are aware of the risks and are competent to perform their duties safely. This training should cover topics such as the identification of hazardous locations, the proper use of explosion-proof equipment, and the procedures for responding to emergencies. It should also emphasize the importance of following safety procedures and reporting any potential hazards. Furthermore, it is important to foster a safety culture within the organization. This involves creating an environment where safety is valued and where employees are encouraged to speak up if they see something that is unsafe. It also involves providing employees with the resources and support they need to perform their jobs safely. A strong safety culture can significantly reduce the risk of accidents and injuries in hazardous locations. When designing and installing explosion-proof systems, it is important to consider the long-term maintainability of the installation. This includes selecting equipment that is durable and easy to maintain, as well as providing adequate access for inspection and maintenance. It also involves developing a comprehensive maintenance plan that includes regular inspections, testing, and repairs. A well-maintained explosion-proof system is more likely to operate safely and reliably over its entire lifespan. Finally, it is important to remember that explosion-proof installations are just one element of a comprehensive safety program. Other elements of the program may include process safety management, hazard analysis, and emergency response planning. All of these elements must work together to create a safe and healthy work environment in hazardous locations.